Good morning, students. Today we are going to discuss about the electrochemical cell and Gibbs energy of the reaction. Now, both the terms are known to you. What is an electrochemical cell? It is a device which converts the chemical energy of a chemical reaction into electrical energy, or we can say that an electrical energy is being derived through a chemical change or a chemical reaction. Students, Gibbs energy, it is also known to you. It is the maximum useful work done, right, and in a process. And student, here since we are studying the chemical reactions, so it will be the maximum useful work that can be obtained from a chemical reaction. In electrochemical cell, students, the system does the work by transferring the electrical energy through an electric circuit. Now, the cell potential, student, it is, that is the EMF of the cell, it is related to the Gibbs energy change. The electrical work done in 1 second will be equal to the electrical potential multiplied by the total charge passed. For a reaction occurring in an electrochemical cell whose electrodes differ in a potential by E cell, the work done is when the amount of charge NF is pushed along by the potential of the cell is given by NFE cell. Right? So, the Gibbs energy of a reaction will be maximum work done or obtained during the chemical reaction, and that maximum work done will be equal to NFE cell. Now student, what is N? It is the number of moles of electrons that is transferred, right, and F is the charge on 1 mole of electron. So when a voltaic cell or a electrochemical cell operates, the work is done on the surrounding as electrical energy flows through the external circuit. So delta G naught will be equal to maximum work done, and that is equal to minus NF E naught cell. And the negative sign here, student, indicates that work is done on the surrounding. Right? This is a sign convention. Now, to find out the standard Gibbs energy, right, we can relate it with the equilibrium constant. By knowing the value of standard Gibbs energy and the EMF of the cell, we can find out the value of equilibrium constant. And the equation that we are going to use is delta G naught equals to minus RT ln K. Now, we know that to predict the feasibility of the cell reaction, delta G naught should be always negative. So, the above equation help us to predict the feasibility of the cell reaction. For a cell reaction to be spontaneous, delta G naught must be, student, negative. That means that E must be positive for the cell reaction. Now, student, just have a look on the numerical related to these equation. Now, I have taken an example of the numerical related to it. Calculate the maximum work that can be obtained from a Daniell cell. So, Zn, half cell Zn2 positive, it's a Salisbury sign double parallel line, then Cu2 positive and half cell copper. Now, the electrode potential are known to us. E naught equals to minus 0.76 for zinc electrode, and E naught for copper is 0.34 volt. Now, first of all, student, we will find out the standard EMF of the cell, that is E naught reduced minus E naught oxidized. So, it is reduction is taking place in the copper electrodes, it is E naught Cu2 positive half cell copper minus E naught Z into positive half cell Zn, and that will be equal to 1.10 when we put the values of E naught. Now students, the delta G naught, that is the maximum work done or the Gibbs free energy, is equal to minus NF E naught cell. So when we put the value, now first of all, what is the number of moles of electron that is transferred in this reaction is 2, because Zn will lose the 2 electron per atom, and the copper ion is accepting 2 electron per atom. So here N equals to 2. And what is the value of the Faraday constant? It is 96500. And the E naught cell that has been calculated is 1.10. So when we put these values, we will get it as minus 212,300 joule. Right. So when we get it converted into kilojoule, we will get delta G naught equals to minus 212.3 kilojoule. So students, here the maximum work done is 212.3 kilojoule that will be obtained by the cell. So just go through it and try to understand the concept and then practice the numericals related to it.